Sri Gurubhyo Namaha children. Welcome to our online teaching academy Ekalaiva. Cbse class 7 science, and the name of the lesson is electric current and its effects. So in our previous class we have learnt about the potential difference, in other words voltage. And in this video we are going to learn about what is a circuit made up of, circuit diagrams, and importance of circuits. Now let's get started. What is a circuit made up of? A typical circuit should contain the following parts: the voltage source, a conductor, a switch, and electrical device. So now let us talk about or learn about these components in detail. The very first thing is the voltage source. So what do you mean by voltage source? Voltage source which provides the electric potential for the electric charge to flow through the circuit. In our previous class we have discussed about the potential difference. So when does the charge will flow? Only when there is the difference in the energy level. Same way, the cell or a battery used to provide the potential difference in order to allow the charge to flow from one terminal to the other terminal. It may be a cell or battery, or otherwise even a power plant will provide the potential difference so that all the electrical appliances can be use the electrical energy. Now let us move on to the next component. The next very important component is the conductor. A circuit must be closed path. It should be a closed path for the electric charge to flow, because charges will flow only in the closed path. If the circuit is open, the charges will not flow. So in order to flow, we need a conductor like a wire. So what type of wire do we use? We need a good conductor, which means this a conductor should provide us a good flow of charge, which means because we do not want to lose electrical energy as heat. So we should use a conductor which has very less loss of heat. Now let us move to the next one. Next we need a switch. Switch is a device that can complete or break the circuit of the electric current. So as I said earlier, the circuit must be closed so that the charges will be flow through that. And the switch is the device which will controls the flow of charge, so that when the switch is open, then the charges cannot flow it, and if the switch is closed, then it will allow the charges to flow through that. So that is the use of switch. Next we'll move on to the next component, electrical device. So electrical device, this may be any appliances, for example bulb, fan, refrigerator, TV, whatever, that changes electrical energy into other form of energy for a useful purpose. For example, if you take a light or a bulb, it will convert the electrical energy into light. And if you take a heater, it will convert the electrical energy into heat. So depending upon our purpose, we need an electrical device in order to complete the circuit. Now, that's all about the components. Now let us learn about the circuit diagram. What is a circuit diagram? Circuit diagram or line diagrams or a pictorial representation of an electrical circuit drawn by using symbols. So far we have learned the components, and those components, as we saw in the pictures, we don't draw like that. We used to use symbols which will represent the particular component. For example, battery. Let us see this circuit. Battery has been represented with the longer line and smaller line instead of drawing like this. Yes, and wires has been drawn as such, and switch, in order to draw a different picture, we are using a symbol for switch. And here is the, generally the bulb will be like this, but we use a symbol to represent the bulb. And wire, there is no change. Okay, now let me show you the symbols of the circuit. So switch, this is the open switch. So if I wanted to close the switch, then I should draw a diagram like this. So this is the open switch where charges will not flow, and this is the closed switch where charges will flow through that. And here is the cell. Cell will be represented with the longer line and the shorter line. Longer line indicates the positive terminal and shorter line indicates the negative terminal. Next, battery. Battery is the combination of cells. So, number of cells together we have to draw. Longer line, shorter line, this is the positive terminal and negative terminal. A negative terminal has to be connected with the positive terminal, and then we have a negative terminal. So this is how the battery will be represented. And then a lamp or bulb will be drawn like this, or otherwise we can draw in this way also. So this represents the lamp or bulb. And then voltmeter. So voltmeter is a device which will use to find out, or which is used to read the potential difference, or otherwise voltage. So voltmeter is a device which is used to measure the voltage, and it is represented with the V letter in a circle. Then ammeter. Ammeter is a device which is used to measure the current in a circuit. So these are the basic symbols which we are using to represent the circuit. Now let us learn about the importance of circuits. Circuits connect a power source to an electrical device to allow the electrical device to work, and also to allow us to use the electrical energy. And the electrical circuits will convert the electrical energy into other forms of energy. So circuits will help us, or help the device to convert the electrical energy into other form of energy. For example, heat energy in case of electrical heater, mechanical energy in case of fan, or washing machine, or mixer grinder, sound energy in case of music system, light energy in case of electric bulb, or electromagnetic energy in case of doorbell. So circuits help the devices to convert the electrical energy into different form of energy. And circuits are constructed for specific purposes in different devices. For example, the circuit which is there in the iron box will be totally different from the cell phone. Okay, so they'll be constructed for a specific purposes. It depends upon the name. That depends upon the device which we are using. Then circuits can have multiple parts. So let me give you an example for this statement. So let us consider this music system or CD player. Okay, in this player, there will be a multiple paths of circuits. Uh, there will be a circuit which will help to convert the electrical energy into sound energy, and there is a circuit which will help the LED monitor to work. So here light energy has been converted into electrical energy has been converted into light energy, and there is a separate circuit which will help the CD lid to open, so where it is converted as a mechanical energy. So in a single device there will be in a multiple paths, and each path will have a specific purpose. So, for example, in a CD player, electrical energy has been converted into sound energy, and also light energy, and also mechanical energy. Okay, children, we'll stop here. Let's continue the remaining in our next class. In order to receive our latest updates, please subscribe our channel. Thank you, children.